Good afternoon to all. Today our lesson is chemical kinetics, lesson number 7. Now we are solving the book bag question, the page number 230, 231, etc. We are going to discuss it. The last class we discussed about up to page number 231, question number 21 we completed. Today we have to start the problem number 23rd to 27, and also one of the important question, repeating board exam question also. Today we have to solve, okay? About the 23rd question, what is about the 23rd means? The rate constant for the first order reaction is about 1.54 to 10 raised to minus 3 second inverse. Calculate the half-life time. How can you calculate the half-life time? Already we learned the theory part, am I right? About the half-life time, what is the formula? T half is equal to 0.693 divided by K. We are substituting the K value here. What is about the K value? 1.54 into 10 raised to minus 3 second inverse. If you are substituting this value, we can easily get the half-life time value. Anyhow, it is one of the compulsory problem, and also this is the board exam question also. Today also I am giving the same question, I am giving the assignment. For each problem, first you should be write the formula. Which formula is applicable to for that particular question. First you take the formula. Then what are the data are given. Then you substitute these values. What are the values given as per the data. Then you write the correct answer and also the correct unit. If you are writing like that, means you can be score 3 marks, 3 out of 3. Okay. First for formula we can be score 1 mark. For the substitution enough, we can be score 1 mark. So 1 plus 1, 2. Next about the answer, and also we can be write the unit. If you are writing like me, we can be score 3 marks. Please all of you take the note, we can be do this problem. Please all of you take the note. Today our learning objectives to learn about the book bag question. Question number 23rd to 27. There is a first volume, textbook, 7th lesson, chemical kinetics, book bag question. Some of the problem we are going to discuss. Okay, there's a question number 23rd to question number 27. What is about the question number 23rd? That means the rate constant for a first order reaction is 1.54 into 10 to raised to minus 3 second raised to minus 1. Calculate its half-life period. Already we know that one. This question already we learned about the half-life period. Am I right? Here, half-life period. We know the formula. What is the formula? Half-life period. What is the formula? T half. Am I right? T half. How can you calculate this one? What are the given data? First you have to write given data. 23rd. That is a T half is equal to 0.693 divided by K. Here what is about the K? K is equal to given the first order reaction. What is the rate constant for the first order reaction? K is equal to 1.54 into 10 raised to minus 3 second inverse. Okay, here. So these are substituting this one, so we can be calculate T half. T half is equal to 0.693 divided by 1.54 into 10 raised to minus 3 second inverse. Am I right? So what's the answer? We get is equal to T half is equal to 450 seconds. This is one of the 3-mark question. For this question, first of all, you should be write the formula. What is the rate constant for the first order reaction? The formula about that the half-life period, half-life time. That is T half is equal to 0.693 divided by K. If you are writing like that, you can be score 1 mark. And next about the substitution. That is t half is equal to 0.693 divided by 1.54 and 10 to the power minus 3 second inverse. If you are writing, that also you will score 1 mark. So 1 plus 1, 2 marks. Next about the t half is equal to 450 second. That is about the second also having mark. So you should be write the unit also. Okay. So you can be easily score the 3 mark question. A very important question. The next about the question number 24. What is the book back question? Question number 24. The half-life of the homogeneous gaseous reaction, that is sulfuryl chloride, SO2Cl2, gives SO2 plus Cl2, which obeys the first order kinetics is 8.0 minutes. How long it will takes for the concentration of SO2Cl2 to be reduced to 1% of the initial value. So, the same formula we are applying here. We know that K, what is about the K? About the rate constant. For the question number 24. First you write K. K is equal to, as per the formula, 0.693 divided by half-life. Okay, that is about that T half. This is the formula. But what are the given data? What are the data? About the, as per the question, we have the data. We know the K value, that is in minutes, am I right? So K is equal to 0.693. The T half already given. How much the T half? 8.0 minutes. Okay, 8.0 minutes. We should be divide that one. 8.0 minutes. Okay. Units, that is equal to 0.087 minutes inverse. Okay, then you should be write the first order reaction. Order reaction. T is equal to 2.303 by K. We are calculating T. Okay, we are calculating the time T. And log A naught divided by A. A naught divided by A. Okay. So, what is about the K? K is already given. What is K? K equal to 0.087 minutes inverse. Okay, K. What is about the A naught? A naught is the final concentration. The concentration, we are taking the final concentration is equal to 100. And what is about the A? A already given that one, it is reduced to 1% of the initial value. Reduced to the 1% of initial value. That is, it can be taken as 1. Okay. Now we are going to substitute what is the answer. Okay, as per this formula. As per the T, we are going to calculate, not K, we are going to calculate time T. So, T is equal to 2.303 by K value already given. What's about the K value? 0.087 minutes inverse. Okay. And about the log of A naught is equal to how much? A naught is equal to 100. Divided by A value is how much? We are taking 1. Okay. So we are substituting this one. Please substitute this one. Substituting this one. T is equal to 52.93 minutes. This is the calculation of T. Okay. This is the calculation of T for the question number 24th question. Okay, please all of you take this question. What is about the next question? Order of the reaction. From this equation, from this question, we know that the order of the reaction is equal to 1. Am I right? Previously discussed. Next, we should be calculate T half. T half, that also we are having T half is equal to how much? 60 seconds. Is that already given? Then we should be calculate K. K is equal to how much? That's a question. We know that K formula. What is about the K formula? K is equal to 0.693 divided by T half. Am I right? This is the formula. Then we have to calculate 0.693 divided by, what is about the T half value? 60 seconds. Okay? 60 seconds. So we get the value 0.01155 second inverse. This is the value of K. Okay? So, next step is to calculate A naught. How can we calculate A naught? Here A naught is equal to how much? 100%. As per the question, A naught is equal to 100%. What is about the T is equal to 180 seconds. What is about the K is equal to already given. What is about the K? 0.01155. This is the K value and also second inverse. What is about the value of A? A we should be calculated. For the first order reaction, we know the formula. What is the formula for the first order reaction? Formula for first order reaction. K is equal to 2.303 divided by T log A naught divided by A. This is the formula for K in the first order reaction. Am I right? So, here which are the data given? Which are the data? The K is already given and T is also given. Am I right? The K is given, T is also given. We shall write that one. What are the data? Okay, K is equal to given. How much? 0.01155. This is about the K. And about the T, the second one is T, is equal to 180. It is also given. And about log A naught. A naught is also almost, we know, how much? 100. So, we should be calculate what? A. A is equal to question mark. Okay. So, we have to calculate this one. Case given. Case how much? 0.01155 is equal to 2.303 divided by T. How much? 180. Okay. 180 is equal to, log A naught value how much? 100 divided by A is the question mark. Okay. So question. So anyhow, we should multiply this one. So what's the answer? As per the cross multiplication, 0.1155 into 180 divided by cross multiplication 2.303, okay, equal to log 100 divided by A. So we are multiplying this one. 0.1155 into 100 into 180 is approximately equal to 2.079 divided by 2.303 equal to log 100 divided by A naught. Okay, this also we have to substitute 2.079 divided by 2.303. The answer is almost equal to 0.9027 is equal to log 100 divided by not A, not A, okay, A. It's not A. Okay. Next, we can substitute the log of log. Now we are going to take the A. Okay. Otherwise, we can write one more step. 0.9027 equal to log 100 minus log A. Log 100 minus log A. Log 100 minus divided means we have to take minus log A. So from we can take log A. Log A is equal to log 100 minus this term 0.9027. Clear? Next one, we are minusing these two terms. Log A equal to 100 minus 0. And approximately the value is become log 100 is equal to, we can write 2 minus 0.9027. Okay, so next one, next time, log A equal to is approximately I am going to write that's about 1.0973. Okay. Next, after finding the log A, you should calculate here log A. So we are going to take anti-log of this value is equal to log of 1.0973. That is approximately equal to 12.5. Okay. So A is equal to 12.5%. This is the answer. Okay. Please take that on. The next question. Question number 26. Question number 26. The zero order reaction is 20% complete in 20 minutes. The zero order reaction is 20% complete in 20 minutes. Calculate the value of the rate constant. We should be calculate the value of the rate constant. In what time will the reaction be 80% complete? How much time required? Okay. In what time will be the reaction be 80% complete? This is one of the question. A zero order reaction is 20% complete in 20 minutes. Calculate the value of the rate constant. In what time will the reaction be 80% complete? That's the question. So, here we should be calculate the rate constant for the reaction. First one is the rate constant for the reaction. Second step is time for 80%. Okay, these are the two steps we have to calculate. So question number 26. The question number 26. We have to calculate. Okay. The first one. What are the given? First you write the given data. Okay. That is, let A is equal to 100 m. A naught minus A is equal to 20. Am I right? 20. Further, first or zero order reaction. K is equal to A naught minus A divided by T. Divided by T. Okay. So calculate A is equal to, what is the value of A naught? A minus K. What is about that? A naught minus we get 20. Okay, am I right? 100 minus A is, that is about we get 20. Time is, we know that 20 minutes. That is equal to 1 minute inverse. Okay. So the rate constant for a reaction is equal to 1 minute inverse. This is the first step. Next, we have to calculate time for 80% completion. Time for 80% to complete. Second one, we have to calculate. Okay. Calculate the time for 80% of completion. Okay. So we have first one is K. K is already previously calculated. K is equal to 1 m minute inverse. About the A naught also we write the data 100 m. Okay. This A naught minus A also we wrote that one. So 80 m. So what is about the time we have to calculate? Time. Okay, time we have to calculate. Therefore we know the formula. T is equal to A naught minus A by K. This is the formula. Okay. So A naught minus A is equal to 80. Here we have 80. 80 m divided by K also given. How much? 1 m. 1 m minute. Minute. Okay. 1 m minute. So that is equal to how much? For T is equal to 80 minutes. This is the answer. Okay. This is how much? 80 minutes. Just only for the understanding this question. Only for the understanding. Okay. Next. Next question is a very, very important question. Question number 27th question. It's a very important question. Okay. Very important question. The activation energy of the reaction is 225 kilocalories mole inverse. And the value of the rate constant at 40 degrees Celsius is 1.8 into 10 raised to minus 5 second inverse. Calculate the frequency factor A. Okay. Calculate the frequency factor. Here, I think that the EA value, activation energy of the reaction, EA value is equal to 22.5 kilocalories mole inverse. Clear? First you have to convert it into having kilocalories. So you have to calculate per calorie. Okay, by multiplying 1000. That's okay. Next about the temperature is equal to 40 degrees Celsius. We have to convert it into Kelvin. The two steps. Okay. One is about the kilocalories mole inverse. If you convert into caloric mole inverse by multiplying 1000. And about the temperature is equal to 40 degrees Celsius. We should be added. It's 1 Kelvin, that is equal to 273. 1 Kelvin is equal to 273 plus 40, we get 313 Kelvin. Okay, and also K also is given data 1.8 into 10 raised to minus 5 second inverse. And R value also we know that one. R value is 1.987, it's a constant value. And about the temperature, T also given, we have the Celsius is converted into Kelvin. Okay, so the data are okay. So we have to find the formula. What is about the formula? Formula is equal to log A is equal to log K plus EA by 2.303 by RT. This is a formula. We can apply this formula. Okay. So we should be write the data. What are the given data? It's a very important question. Question number 27. Okay. The activation energy. Here, what are the given data? What are the given data? Okay. Here, EA is equal to 22.5 kilocal mole inverse. To multiply by 1000 to change the kilocalories. Okay, multiply by 1000, it will become as a calorie. Okay, 22.5 into 1000 is equal to 22,500. Okay, converted into calorie, that is a cal mole inverse. So first step. Okay. Next one is the temperature. T is equal to 40 degrees Celsius. It is given in the Celsius. How to convert it to Kelvin? Okay. So we are adding 1 Kelvin is equal to 273. So just we are adding, that is 40 plus 273 is equal to 313 Kelvin. So A over T also over. Next about the K. K is also given. Rate constant K is also given. K is equal to 1.8 into 10 raised to minus 5 second inverse. Okay, second inverse. Next one is R is also a constant value, is equal to 1.987. This is also okay. Then what is the formula? About the formula, log A minus log K, log A is equal to log K plus EA by 2.303 RT. This is the formula. Okay, clear? This is the formula. Then we can substitute this formula. What is the substitute this value? Which are the values are given? Here we have to K is also given. K having, EA also having, R also having, T also having, everything having. So how to find out the value? Log A is equal to log of K. How much? So 1.8 into 10 raised to minus 5 plus. What is about the EA? What's about the EA? EA is equal to 22,500 divided by, what is about the 2.303. What's the value of R? 1.987 into, what's up with the temperature? 313. Okay. Okay. So first you should be multiply this one. Multiply 2.303 1.987 into 313. So what's the answer? Log A is equal to log 1.8 into 10 raised to minus 5 plus, we are multiplying. So what's the answer? 2500 divided by, multiply, the answer is about, I think that about 1432.307. Okay. Okay. So next one, you have to divide this one. Log A equal to log 1.8 into 10 raised to minus 5. We are dividing, we get answer 5.7089 approximately, like that. Okay. So it should be add, okay. It should be add. Then, right? Log A is equal to 1. Log of 1.8 10 raised to minus 5. Okay, so minus 5 plus 5.7089. Okay. Log of A equal to 10.9642. Okay? 4. A is equal to antilog. We are taking the antilog of 10.9642. About the antilog, A is equal to 9.208 to 10 raised to about 10. What is the second inverse? This is the answer. We can learn one of the board exam question, repeating board exam question. Let's show that in case of first order reaction, the time required for 99.9% completion. Okay, completion. Okay, is nearly 10 times. 10 times the time required for half completion of the reaction. This is one of the board exam question. So that in case of first order reaction, the time required for 99.9% of the completion is nearly 10 times. The time required for half completion of the reaction. The time required for half the completion of the reaction. Okay, it's a question. So what are the data given? Okay, what are the data? A naught is equal to 100. This we know that. When T is equal to T 99.9%. The time T is equal to 99.9%. A is equal to 100 minus 99.9. That is equal to 0.1. Okay. What is about the formula for this reaction? Which formula is applicable means K is equal to 2.303 by T log of A naught by A. This is the formula. It can be applied. Okay. So here we are taking T. Okay, so T 99.9% equal to 2.303 by K log of A naught by E. Okay, yeah. So next we are going to substitute this value. Which are the substitution? Okay, substituting this value as per this formula. We can be substitute. Okay, so T 99.9% is equal to 2.303 by K log A naught. What is about the A naught value? 100 log 100 by A value approximately equal to how much? 0.1. 0.1. Okay. Yeah. So we are dividing, we get the 100 divided by 0.1 is approximately 99% is equal to 2.303 by K log of 1000. Clear? Log 1000 value, all of you know that one. Log 1000 is 3. So T 99.9% equal to 2.303 by K 3. Okay, here we have to multiply by 3. Multiply by 3. So T 99.9% equal to, now multiply we get 6.909 divided by K. Okay. Here the question is time required for 99.9% completion is nearly how much time? 10 times. How much time? 10 times. So T 99.9% okay is equal to 10 into 0.69. Okay, 10 into 0.69 divided by K divided by K. That is equal to T 99.9% equal to 10 into T half. 10 into T half. This is the answer. Okay. About today assignment, which question means you can write the question number 23rd question. Okay. The assignment is question number 23rd. The last class many of them wrote the assignment. So kindly please all the ways you write the assignment. If you have any doubt, please call me. Okay. We have our today assignment. Book back. Question number 23rd. Okay. Thank you all of you. Thank you. Have a nice day.